So, what is the prisoner's dilemma? The story is that there are three prisoners. Let's say they are A, B, C, and they all know that two out of the three will be released. And then say prisoner A wants to ask the friendly guard that which of the prisoners other than himself would be released. And he hesitated because he reasoned that the probability of him being released is equal to 2 over 3 before asking. And he being released is going to be 1 over 2 after. Because, for example, if the guard says B, then it's either A or C who is the other one that is going to be released. So it's 1 out of 2. And the question is, what is wrong with A's reasoning? The idea is that we need, first of all, have to specify a correct probabilistic model before we try to find out the probability of a particular. In particular, A's implicit assumption here is that if the name of B is given by the guard, then the probability of A being released is the same as the probability of C being released. In other words, he calculated the probability of this event by dividing the size of the event, which is the number of sample points, over the size of the sample space. And one important thing to keep in mind is that this is only true when the sample points in the sample space are all equally likely to happen. That's an important point for you to keep in mind. Now the question is, given B is A or C, the other prisoner to be released equally likely? And the answer is no. Let's find out. The idea is that we only know, to start with, we only know that 2 out of 3 of the prisoners will be released. And So it will be either A and B, or B and C, or A and C. So each of these would happen with probability 1/3, 1/3, 1/3. In this case, because it's A who is asking the guard, so the guard has to say B. In this case, because A is not among the two, so the guard can say A, can say B. He can also say C. In the last case, the guard has to say C. So we know this has probability 1/3, and these two combined has probability 1/3, so each of them has a probability 1/6, assuming the guard is equally likely to tell A whether it's B or C. And lastly, this is probability 1/3. So we have 4 numbers. Now, for example, we want to calculate the probability that A to be released given the guard says B. And the probability, so that's equal to the probability of A released and guard says B divided by the probability of guard says B. The guard says B at 2 locations. Here, the guard says B, and here the guard says B. So that event happens with probability 1/3 plus 1/6. The probability for A being released and the guard says B is only here, because the second case is it is B and C who are released. So A has probability 1/3. By carrying this out, we know that's equal to 2/3, which is the same as before asking. So we know the prisoner's reasoning is wrong, and asking or not wouldn't affect his probability of being released.